morning, class. So today we are going to just spend this day reviewing what we've done the last 3 days. So section 7.1 was just going over sequences and series in general. Section 7.2 was specific to arithmetic sequences and series. And then 7.3 was specific to geometric sequences and series. So today I'm just going to go over the review sheet for the quiz. The quiz will be on Monday technically, although I will probably post it on Friday for those of you that want to kind of get a head start on it and then have off on Monday. So that'll be your choice. It'll be due midnight Tuesday, and we'll continue on with the next lesson Tuesday. So that's kind of where we're headed. In any event, so our review for quiz, sequences, and series. So the first 5 terms in the pattern, if we take a look at this rule right here, okay, the first 5 terms, that's just telling you that you want to substitute in the numbers 1 through 5 in for n, and then find out what those numbers are in the sequence. So the first number in the sequence is going to be what you get when you plug a 1 in for the n. So 1 squared is 1, and 1 plus 2 would be 3. So the first number in the sequence is a 3. Then you would plug in a 2 to find out, well, what's the second term in the sequence? So 2 squared is 4, and 4 plus 2 is 6. The third term in the sequence, 3 squared would be 9, plus 2 would be 11. So that's the third term in the sequence. The fourth term, 4 squared is 16, plus 2 is 18. So that's the fourth term in the sequence. And then finally, the fifth term, 5 squared is 25, plus 2 is 27. So that's all you have to do to find the first 5 terms in the pattern. You just substitute in the numbers 1 through 5. Again, if you're using a graphing calculator, you could just put this in on your calculator as well. So you would do y equals x squared plus 2 on your calculator, and then you would just look up your table of values. So that's a way you can do it on there. Number 2, find the sum of each series. So when we're doing this series, that means we're finding those numbers in the sequence, and then we're going to add them together. So the first number in the sequence is what I get when I plug in that 1. So I'm going from 1 all the way up to 7, and then I'm going to add them together. So if I put in the 1 here, 1 minus 1 is 0, and 0 times 2 would still be 0. So that's my first term. Then my second term, 2 minus 1 is 1. 1 times 2 is 2. Then my third term, 3 minus 1 is 2. 2 times 2 is 4. Then my fourth term, 4 minus 1 is 3, and 3 times 2 is 6. Then my fifth term, 5 minus 1 is 4, and 4 times 2 is 8. The sixth term, 6 minus 1 is 5, and 5 times 2 is 10. And then the seventh term, 7 minus 1 is 6, and 6 times 2 is 12. So now we would add all of those together. So 2 plus 4 plus 6 plus 8 plus 10 plus 12. So let's say we got 20, 30, 42, if I added that correctly. And that would be the sum for that series. Some of the newer calculators do have the summation notation on the calculator. Mine does not have it, and I can't remember exactly where it is. I want to say it's somewhere in the math menu, but it is in there if you have one of those newer calculators. Yeah, I can't find it right now. So that's an option, but really it's simple. You're just plugging in numbers. Again, you could also use the graphing part of your calculator to type in the 2 times n minus 1 and then get the numbers off the table and just add them up that way as well. Okay, so going on to the next problem. This time we're going to be plugging in the numbers 0 through 5. So obviously I'm going to plug those numbers in for this variable here, and then what I get, my numbers in my sequence, I'm going to add them together. So when I plug a 0 in, I end up with a 2. When I plug the 1 in, I have 3 plus 2, which is 5. When I plug in the 2, 3 times 2 is 6. 6 plus 2 is 8. When I plug in the 3, 3 times 3 is 9, plus 2 is 11. When I plug in the 4, I have 12 plus 2, which is 14. And when I plug in the 5, 3 times 5 is 15 plus 2, which is 17. And now I want to add those together. So you can just add them in your head, add them on the calculator, and you should get 57 for your sum. So here is the series, 0, 2, 4, 6, 8, 10, 12, and the sum is the 42. And this series is 2 plus 5 plus 8 plus 11 plus 14 plus 17, and that sum would be 57. All right. So now the next thing we're going to go over is deciding whether or not a sequence is arithmetic or geometric or neither. So remember, if it's arithmetic, you're either adding or subtracting the same number. Geometric is basically you're multiplying or dividing by the same number. And remember, when you're dividing, you're really just multiplying by a fraction. And obviously, if it's neither of those, it's neither. So you want to look at the pattern, what's happening here. So to get from 1 to 7, and then 7 to 13, and 13 to 19, we're adding 6 to the previous term. So this would mean that this is arithmetic. And our common difference is positive 6. Now, if we take a look at example B, this time the numbers are decreasing, and obviously they're different amounts. So if I do 200 divided by what would give me 20, or multiplied by what would give me 20, right? So let's see if I'm thinking about this. So 200 divided by 10, right, is 20. 20 divided by 10 is 2. 2 divided by 10 is 2/10. Now remember, when we're dividing by 10, we're really multiplying by 1/10. So we can see that this is, sorry, that's really sloppy. We can see that this is a geometric pattern, and that means it has a common ratio, which in this case is 1/10. It always has to be the multiple that makes your common ratio. Now remember, if you can't figure out that common ratio just from looking at the pattern, you can take a number in your pattern and divide it by the preceding number. And if it's a fraction, you'll simplify it. So 20 over 200 would simplify to 1/10, or 2 over 20 would simplify to 1/10, or so forth. All right, let's take a look at B and D. So for B, to get from 2 to 4, I could add 2, I could multiply by 2. So going from 4 to 16, though, I would have to multiply that by 4. And then to go from 16 to 64, I would multiply by 4. But to go from 2 to 4, I would only multiply by 2. So this would be neither, because the pattern is not constant. The pattern is not adding the same thing each time, or multiplying the same thing each time. And then finally, this last one, we're decreasing by 3 each time. So we're decreasing by the same number repeatedly. We know that that is arithmetic. And it has a common difference, and this time it's a -3 since it's decreasing by 3 each time. Okay, so now we're going to write a rule for the nth term of the arithmetic sequence, and then after we write the rule, we're going to find a sub 12 and a sub 17. So we'll use the rule that we come up with, and we'll substitute in a 12 and a 17 and get those numbers in the sequence. The formula is over here on the left-hand side, so it's a quick, easy reference. Okay, so first of all, to write the rule, remember we need two things. We need the a sub 1, and we need the common difference. So we know these are arithmetic because it's telling us that in the directions. So right away, I can know that my a sub 1 is the 5 because that's my first term. And then I have to find my common difference, which is going to be that number that's being added or subtracted each time between the numbers or the terms in the sequence. So to get from 5 to -2, I would have to subtract 7. To get from -2 to -9, I would have to subtract 7. From -9 to -16, I would subtract 7. So my D is going to be -7. So when I go to write my rule, I'm plugging in my a sub 1, which is 5, plus the -7 times the n minus 1. Now remember in the notes, I think the d was on the right-hand side of those parentheses. Here it's on the left. It doesn't really matter because you're going to distribute it anyway. So you can't leave your answer like this. You have to simplify it. And remember, these are all called explicit rules. That's not so important right now, but next week when we get into recursive, this way you'll know which one we're talking about. Okay, so if I distribute the negative 7, I get negative 7n plus 7. Then I'm going to combine my like terms. So my rule will be a sub n equals negative 7n plus 12. So that's my rule. So now I want to find a sub 12. So to find a sub 12, all I'm going to do is plug in a 12 for my n and work it out. So negative 7 times 12 plus 12. That's all you need to do. So we have negative 72. Okay, then we're going to do the same thing for the A17 here. So to find my A sub 17, I'm just going to plug in that 17. So negative 7 times 17 plus 12, and that gives us negative 107. And that's it. All right, so let's try it for the next one. So for the next problem, I can see that my pattern is increasing here. So what's it increasing by? To get from 32 to 47, I would have to add 15. From 47 to 62, I would have to add 15. 62 to 77, add 15. So my common difference is positive 15. And we know that my a sub 1 is that first term, which in this case is 32. So to write the rule, I'm using the formula over there on the left. So my a sub 1 is 32. And then I'm going to have plus my d value, which will be distributed to the n minus 1. So we have 32 plus 15n minus 15. And then I combine my like terms. So 32 minus 15 gives me 17. And that is my explicit rule for this particular sequence. So now I'm going to find a sub 12 by simply substituting in a 12 for the n and then working that out. So 15 times 12 plus 17 is 197. And then we're going to do the same thing with the 17. So if I want to find the 17th term in the sequence, I would simply put in a 17 for my n value. So 15 times 17 plus the 17, and I would get 272 for the 17th term in the sequence. Okay, so now we're going to find the sum of the first n terms of the arithmetic series. So again, we're still working with arithmetic, but this time we're going to find the sum of the numbers in the sequence. So then you call it a series when you're adding them together, and then you find the sum of it. Now, this formula, we need the a sub 1, we need the a sub n, and we need the n. Now, they're giving us the n. They have to give you the n. They can't say find the sum and not tell you how many terms they want you to find the sum of. So that's got to be given to you. The a sub 1 is usually given to you, especially if they list out the series like that, then it's definitely given to you. So in this case, it's just a 1. And then we need to find the a sub n, and we're going to use the formula from the previous page like this, and then we can find it. So the a sub n, in this case, we would be finding a sub 8, because that's what we're going up to, the 8th one. So we would have to do 1 plus the d. So you're going to have to look at the pattern and find the d. What is our d here? 3. And then n minus 1. And then you can just calculate that out. So 8 minus 1 is 7. 3 times 7 is 21. 21 plus 1 would be 22. So now once you have that information, you can plug into the sum formula. So we're going to have 8. And then you're going to have on the top 1 plus, and we just figured out that was 22, divided by 2. So remember, you're essentially adding up your first number in the series and the last number in the series that you're finding the sum for. So the first number was 1. The 8th number would be 22. So we're averaging those out. So you have 23 over 2, which is obviously a decimal. And then you're going to just multiply it together. So you would have 23 over 2, which is 11.5 times 8, and you would have 92 as the sum of those 8 terms in that series. So when we're looking at the next example here, we're given the n value. So we know the a sub 1 is 20. If I look at my pattern here, I can see it's decreasing by 2. So I know my d is negative 2. And then to find my a sub n, which in this case is an a sub 8, or sorry, it's an a sub 25, my bad. I'm going to use the formula from the previous page, right? So I have a 20 plus, and then it's negative 2 times 25 minus 1. So 25 minus 1 is 24. 24 times negative 2 would be negative 48. And then you're going to end up with negative 28. So once you get all those 3 pieces, you can use the formula over here on the left. So my n value is 25. Then I'm going to average out my first term, which is 20, and the 25th term, which will be negative 28. So that is going to give me a negative 8 over 2, which works out to be negative 4. And so then when I work that out, I end up with negative 100 for the sum of that series. Okay, so moving on, just to review the geometric rule and also the sum formula. So if we take a look at the next one, write a rule for the nth term of the geometric sequence, and we're going to find a sub 7 and a sub 9, and this is the rule over here. If you remember, I did mention I always think it's very important to put parentheses around the r value. If it's positive, technically you don't have to, but you might as well put it that way. You don't have to worry about forgetting it. So to write the rule for geometric, we need both an a sub 1, and then you need the r, which is that common ratio, or the number that's being multiplied from one term in the sequence to the next. So a sub 1 is the first term, that's negative 5. Now to get from negative 5 to positive 10, we would have to multiply by negative 2. And we would multiply by negative 2 to get from 10 to negative 20 and so on. So the r value is negative 2. You can also use that ratio method where you take the number and divide it by the preceding term. So 10 divided by negative 5, negative 2, or negative 20 divided by 10, negative 2. So to write the rule, you don't have to actually do any simplifying or anything, so you just plug it in. So the negative 5, parentheses, negative 2 raised to n minus 1. So I really like the geometric ones because writing the rules is pretty straightforward. You're just plugging in the a sub 1 and the r. So now to find the a sub 7, all you do is plug in a 7 for the n value. Just be careful, make sure you're using PEMDAS when you're figuring this out. So when I go to find my a sub 7, I have to do this little exponent part first, right? The 7 minus 1 is 6. So if you're putting this all in a calculator, you're probably going to need to put parentheses around that. Unless you have one of the really new calculators, you won't need to because you'll bump it up. The older ones, you'll need parentheses. So I would probably just do what you can in steps. So I would just do 7 minus 1 in my head. I know that's a 6, right? Negative 2 to the 6th power is going to be 64, and then 64 times the negative 5 in the front. And then that would give me negative 320. Then when we go to do a sub 7, or sorry, a sub 9, I have negative 5 times negative 2, and this time it's 9 minus 1. But again, I can do 9 minus 1 in my head, so there's no sense in me putting 9 minus 1 in my calculator, right? 9 minus 1 is 8, so I'm going to do negative 2 to the 8th power. Now you should get a positive 256, and then you're multiplying that to the negative 5. So you should have negative 1280. So just a couple reminders on the calculator to be careful of. So if you were putting this on the calculator and you didn't put parentheses around the negative 2 and you raise it to a power, especially in this case, you're raising it to an even power, which would cancel your negatives out. If you don't have parentheses, that's not going to happen and your answer is going to be wrong. So it's really important. Whether you're using it on the calculator or in your head, just you have to make sure you don't forget that. Okay, so now the last one here. So this pattern, it looks like I am, let's see. It's hard for me to look at this and know, what am I multiplying by, right? So I'm going to go reverse, and I'm going to do 9 divided by 6, and that simplifies to 3 over 2. And then I'm going to try 6 divided by 4, and that simplifies to 3 over 2. So my R value here is going to be 3 over 2. And my A sub 1 is 4. So because I didn't know that pattern off the top of my head, I had to use that ratio situation there to figure that out. So A sub n equals my first term, which is 4, times my R value, and I'm putting it in parentheses, raised to n minus 1. So that is my geometric rule right there. So now I'm going to find my A sub 7 by putting in the 7 there. So now this is like an example of where I'm going to do this on my calculator, right? So on my calculator, I'm not going to worry about the 7 minus 1. I just know that's 6 in my head. So I'm going to do 4 parenthesis 3 divided by 2, and then I'm going to raise that to 6. So it's going to look like this. Sorry, you can see that hopefully. And then you get the 45.56. Now, if I go to math, make sure fractions highlighted, enter, I get 729 over 16. So that would be my answer for that one. And then for A sub 9, I'm going to do 4 times 3 over 2 to the 9 minus 1. So again, on my calculator, 4 times parenthesis 3 divided by 2 parenthesis raised to, I know 9 minus 1 is 8. So I'm just going to type it in that way. And then my answer is 102.5, but I want a fraction, so math, fraction, enter, and I get 6561 over 64. Okay. And then the last thing we're going to review is the summation formula for geometric series. So find the sum of the first n terms of the geometric series. So for this one, you basically need 3 things. You need the A sub 1, you need the R, and you need the N. So we're given the N. You remember, you have to be given that. You can't find a sum if you don't know how many terms in the sequence you're finding the sum for. Your A sub 1 is right there. That's given to us. And then the R value you're going to have to find using that common ratio, right? So if I do, let's see, 24 divided by the preceding term, which is 32, I get 3/4. If I do 18 divided by the preceding term of 24, I get 3/4. So I'm confident now that my R value is 3/4. So now to do this formula, my A sub 1 goes on the outside. The numerator is 1 minus that R value raised to the N. And the bottom is 1 minus that R value. So now remember when I did this one in the lesson yesterday, I talked about you just want to do things on the calculator one at a time. So the first thing you want to do is just the numerator, the 1 minus 3/4 to the 12th power. So when you enter that 1 minus, then the 3/4 would go in parentheses, and I would raise that to the 12th power. So it's just going to look like this. 1 minus 3/4 raised to 12. Now I hit enter, and I get this crazy decimal on my screen, 0.963, blah, 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 right? So you're going to leave that there, and you're going to divide it by 1/4 because you probably could do 1 minus 3/4 in your head, right? So I'm going to leave this on my screen and I'm going to write minus 1 divided by 4 in parentheses. If you want to do 0.25, since that's an exact decimal for that fraction, you could. And so now we have 0.7183, whatever that is. And then you're going to just multiply that by the 32. And you will have 22.9863, which we're going to round to 99. You don't want to do any rounding until that very last step, and then you can round to 2 places. All right, and then the final one here, I have my n, which equals 16, my a sub 1, which I can tell is 2, and then I want to find that common ratio, or that r. So what is being multiplied? So it looks like I'm multiplying by -2 each time to get to the next term, so my r is -2. So my sum formula would be my a sub 1, which is 2, 1 minus -2 to the 16th power over 1 minus -2. So again, we want to focus on just getting that numerator portion on the calculator. We're just doing this part here on our calculator. And then 1 minus a -2, you probably know that that's going to be 3. So on my calculator, I'm going to do 1 minus parenthesis -2 parenthesis raised to 16. So it's going to look like that. Sorry, there's a glare, so I'm trying to make sure you can see it. So 1 minus -2 raised to 16. You hit equals, and you'll have this number here, this -65535. Leave it on your screen, divide it by the 3 that you get from doing 1 minus -2. And then that number can stay on your screen. You can multiply it by the 2 from out front the parentheses. And then you get this -43690. Okay, and that's basically it for our review today. So if you have any questions, just send me on the remind. That's the best way to get in touch with me to get the quickest response. If you send me a message on Google Classroom or email, I'll get it, but it's going to take longer. So I don't check those constantly, but I see the reminds on my phone, so I can get back to you a lot quicker if you have a question to send on there. And that's it for today. For Friday, I will have a little review homework assignment on there as well from the quizzes. And then the real quiz will come out. It's technically Monday's assignment, so if you want to do it early and have Monday as a break day, then that's totally up to you. But if you need the weekend to kind of go over things or catch up on things and you're not going to take it till Monday, then that's fine too. And that's it. Hope you guys have a great weekend.